And I'm Ashwara. Today we are discussing about class 12 physics chapter number 5. In this lecture, we'll discussing about that the magnetic properties of the materials. Okay, so there in this lecture, we'll discussing about that the magnetic properties of a material. It means there are the different types of magnetic properties are there. So discussion in this previous sections help to classify the material has a diamagnetism, diamagnetic, paramagnetic, ferromagnetic. See here the diamagnetism, paramagnetism, and the ferromagnetisms are there. So, in terms of the susceptibility, chi, a material is diamagnetic is when the chi is negative, para is positive, and the small and ferro is chi is large and positive are there. Okay, what is that? There are the it is magnetism. It is depends on the this is the diamagnetism, paramagnetism, and also ferromagnetism. It is a depends on the value of chi. What is the chi? Chi it is a susceptibility of that of the susceptibility. Okay, so see here now we already discussed in the previous lectures are there. So magnetic chi is known as the magnetic susceptibility. So see here we will discussing about that. Now see gives the filling this material they are the positive number introduce the qualifying the paramagnetic materials, and we describe see here we will show in the next slides. But see here, first of all, the magnetism, there are the different things are there. First one is the all metals are in the diamagnetisms are there and arising out of the band structures of metal. We will discussing in the after that our this 12th science in the college we will discussing about the arising of out of band structures of metals, but just I explained to this phenomena due to this year. What is that? So now, what is the see here the paramagnetism non-interacting atomic part moments are there. Due to this is the Curie paramagnetisms, and also when arising of the of atomic magnetic moment due to the permanent magnet, and it has a spin plus orbital motions are there. So see here it is a it gives the interacting the atomic moments. There are the also there are the three different paramagnet has a three different things are the ferromagnetism, ferrimagnetism, and anti-ferromagnetisms are there. So and also then due to the band structures of metals, there are the poly spin paramagnetism, band ferromagnetism, and band anti-ferromagnetism. These things is not we require in these chapters, but just know for knowledge I am showing to you. So see here we need to just understood this diamagnetism, Curie paramagnetism, and also paramagnetism. Ferrimagnetism we just understood here. Okay, so see here now. First one is that the paramagnetism. So the properties of all materials is response to an applied magnetic field, and hence there is a no requirement for the atom to have the net magnetic moments. Okay, so there is a no net magnetic moments is required. So this is a weak weak negative magnetic effect. Kite is equal to 10 to minus 5, and hence may be masked by the presence of the strong effect like the ferromagnetism, even though it is a still presence. Now we know about that the diamagnetism example is that water is the example of the diamagnetisms. Now, this is the a simplified understanding of diamagnetism effect is based on the Lenz law applied to the atomic scales. So, Lenz law states that the change in a magnetic field will induce a current in a loop of electric conductor, which will tends to oppose the applied magnetic field. It means they are the opposing to the applied magnetic field. So, as the electron velocity is a functions of the energy of the electronic states, the diamagnetic susceptibility is essentially independent of the temperatures, and the diamagnet tends to the exclude lines of force from the materials. And now see here, a superconductor under some conditions is a perfect diamagnet, and it is exclude all the magnetic lines of force. But see here, closed cell electronic configuration leads to net zero magnetic moment. Spin and orbital moment are oriented to cancel out each other. So monoatomic noble gas He, argon, krypton, okay, helium, neon, argon, krypton, etc. are the diamagnetic in the polyatomic gases, and H2, N2, etc. Polyatomic gases mean hydrogen gas, nitrogen gas, This is the polyatomic gas. The also it is a diamagnetic. The formations of molecules leads to the closed electronic cell configurations, thus making this gas diatomic. Well, a diatomic, many ionically bonded NaCl, MgO, etc., and also the covalently bonds like a carbon, diamond, germanium, silicon material also leads the closed cell configurations, thus the making diamagnetism as the paradominant magnetic effect. The most organic compound involving all other types of bond as well as the are diamagnetic. Now see here, let's simplify the understanding the diamagnetism based on the Lenz law. First one is the electron pair in the same orbit, electron pair in the same orbit, moving with the velocity v, cancelling each other magnetic moment. See here, there are the two electrons are there. Okay, electrons pair in the same orbital moving with the velocity v. See here, it is going in this side and it is going in this side. On that time, the cancelling each other magnetic moments and b effect of n increasing the magnetic field b on the magnetic moment m1 increase and m2 decrease. So see here there are the m1 and m2 is same. See here m1 and m2 is m1 is increase, m2 is decrease, so that the net magnetic moment oppose the field b. Okay, so there are the it is opposing to field b. See here the M versus H, the magnetization versus the magnetic field intensity plot the diagrams of that. So see here, this is the gives the paramagnetism magnetic and this gives the diamagnetic. So it means that the magnetic intensity is very low in this phenomena. So and how it's related to the magnetic intensity, the m it is equals to m also related to the m it is equals to chi into chi. What is the chi is the susceptibility of the magnetic fields are there. So this is the it's related to it. Now, before it the simplest diamagnetic examples are that diamagnetic is so electron in an atom orbiting around the nucleus possesses the orbital angular momentum. These orbiting electrons are equivalent to current carrying loop and thus the process orbital magnetic moment. And now diamagnetic substances are where are the ones in which resultant magnetic moment is an atom is zero when magnetic field is applied. So those the electrons having orbital magnetic moment in the same direction slow down and those the opposite direction speed up. This happens due to the induced current in accordance with the Lenz law, which we will study in the chapter number 6. Okay, so this in the chapter number 7 we will discussing about that the substance develop need magnetic moment in the directions opposite to the applied field and hence the repulsions are there. So this is the basic phenomena are there. So now see here the diamagnetic materials are bismuth, copper, lead, silicon, nitrogen at standard temperature pressure. What and the water and the sodium chlorides also are there. So diamagnetism is present in all substance. Okay, diamagnetism is present in all substance. However, the effect so weak in a most case that it the gets shifted by other effect like a paramagnetism and the ferromagnetisms. It is it. So the most exotic diamagnetic materials are what is that? Diamagnetic materials are the superconductor. These are metals cooled at to very low temperature which exhibit the both perfect conductivity and the perfect diamagnetism. Here the field line are completely explicit. X kite is equals to -1 and mu r it is equals to 0. A superconductor repel the magnet and is repelled by the magnet. Okay, so the phenomena of perfect diamagnetism is superconductor is called the Misner effect. We will discussing in the college, but after that, after the name of the its discovered superconducting magnet can be gainfully exploit in a variety of situations. For example, for running magnetically leviated superfast trains are there. So we know about that the quantum levitations are there. So in the quantum levitation what will happen, there are the if we are using the two magnets on and on the time and we are supposing when we have the magnet, okay, when we are magneting due to the in the liquid nitrogen and place on the magnetic field on that time, it will be moving without the accelerations. Okay, it will be moving without accelerations. It needs just a small force to the movement of that. So that's why it is known as the quantum levitations. And due to this quantum levitation, today recently we are using that the uh, train also, our trains are there. Now see here, the paramagnetisms. So there are the two types, two distinct types of the paramagnetisms are there. First one is that arising when the atom's molecule has net magnetic moments, and second one is that comes from the band structures, Pauli spin or weak spin paramagnetism. But here we are just discussing about that the simple things are there. Okay, so see here, if the net magnetic moment do not cancel out, then the materials is a paramagnetic. Okay, for oxygen for example has a net magnetic moment is mu is 2.85 mu into b per molecules. A point to be noted here is that even if there are many electrons in the atom, most of the moment cancel out, leaving a resultant of a few magnetons. In the absence of the external field, this magnetic moment point in the random directions and the magnetizations to the specimen is zero. So when the field is applied to the factor come into the pictures. Now the align force on the magnetic field, we have already seen that the this alignment means the disordering tendency of the temperatures. There are two phenomena, aligning force of the magnetic fields and also the disordering the tendency of the temperatures. So the combined effect of these two factors is that only partial alignment of the magnetic moment is possible. The susceptibility of the paramagnetic materials has small value. For example, oxygen has a chi m, it is equals to point oxygen chi m has a 20 degree centigrade, it is equals to 1.36 into 1.36 into 10 raised to minus 6 meter cube upon kg. So that this is the parts alignments are there, and the susceptibility of the paramagnetic materials is very small are there. So see here, the paramagnetic materials is inversely proportional to the absolute temperatures T. And second thing is that the tendency of temperature. So it is related to the temperature. But first of all, two types of paramagnetic can be differentiate. Those which are always paramagnetic, which with the no other details to be considered, and those which are ferromagnetic, ferrimagnetic, or anti-ferromagnetic, and becomes a paramagnetic or heating. This will have a non-zero value for theta in the Curie Weiss law we are discussing above. So see here, now what is that? Any magnetic alignment is always fighting against the disordering effect. Second thing is that effect of the temperatures. Okay, so second thing is that effect of temperatures are there. The paramagnetic materials are aluminum, sodium, calcium, oxygen at STB. STB means the standard temperature pressure, and the copper chloride. Experimentally one find that the magnetization of the paramagnetic material is inversely proportional to the absolute temperature T. So M it is equals to C V0 by B0 by T. See here, we are using that the chi M it is equals to C into T by T minus theta z. So this is known as the Curie's law. See here, the magnetic alignment is always find against the disordering effect of the temperature, while mass susceptibility chi m is independent of the temperature. For a general paramagnetic is follows the Curie's laws. So theta is approximately Tc, where chi of m it is equals to C upon T minus, where chi m is the mass susceptibility and C is the Curie constant, and theta is the unit of temperature and is measure of the interactions of the atomic magnetic moment. So usually thought of the as initial molecules, atomic field, the concept of exchange integral, which will deal with the context of the ferromagnetisms. So in the quantum mechanical equivalent of this, now actually the molecular field is force upon torque tending to align the adjacent atomic moment. So it is typically value of 10 raised to 9 A upon A by M and is such much stronger than any continuous fields are produced in a lab. Ampere into meter. Now there is a no interactions between the atomic magnetic moment, then theta is equals to 0, and the Curie is law reduced to the Curie law. The variations of the susceptibility for the key kinds of the behavior as shown in theta. Okay, see here there are the thetas are there. Okay, see this is our theta, the Curie's Weiss law and Curie law and the Curie's Weiss law. So and the paramagnetic material, there are the two different phenomena is that what is that the see it is a positive values are there on that time chi m it is positive and this it is a 0. See here there are the diamagnetic materials are there and there are the this is our see here this is the diamagnetic materials are there, paramagnetic materials are there. Okay, so variations of mass associated with the temperature in a kelvins are there. The Curie law and the Curie-Swiss law with the positive value of theta. The behavior of the diamagnetic material is shown in for a comparison. Diamagnetic has small negative susceptibility, which essentially does not change with the temperatures are there. So see here, this is known as the Curie's law. After it discovered the Curie, that constant is called the Curie's constant, and the paramagnetic materials, both the chi and mu, are depend not only on the material but also that it depends, but also on the sample temperatures. As the field is increased or the temperature is lower, the magnetizations increase until it reaches the saturation value ms, and at which point all the dipoles are perfectly aligned with the field. Beyond this, Curie's law is no longer valid. Okay, so it is a no longer valid, but still up to we are discussing about that. So after that, guys, today we are discussing this much only. After that, we will discussing about that our topic is ferromagnetisms. Okay, so today we are just this much only. After that, we will discussing about the ferromagnetism and also the permanent magnet and the electromagnets are there. So in the in the lecture, okay. So thank you guys. Thank you so much.